Edexcel Core Pure, Calculus 2, Improper Integrals. Integrals that cross a value where the function is undefined. Here we would like to integrate 1 over x minus 1 squared between the limits 0 and 3. However, we can see from the diagram that this function is undefined at x equals 1 and that the area crosses that undefined value. In order to deal with this type of integral, we're going to split the function at the problem value of 1 and to see what happens as we approach that value. So instead of integrating the function from 0 to 3, I'm going to look at the limit as a tends to 1 from 0 to a for this particular function. And then look at the integral from a to 3, and the limit as a approaches 1 from a to 3 of this particular function. So when we integrate 1 over x minus 1 squared, we get minus 1 over x minus 1, and the limits will be 0 to a. And when we integrate this time, we're going to get minus 1 over x minus 1 with the limits a to 3. And now subbing in the top and the bottom limits. So the top limit going in, so that's minus 1 over a minus 1 minus bottom limit going in plus the limit as a tends to 1, so the top limit going in is minus a half minus minus, and the bottom limit a going in now. If we let a approach its limit, which in this question is 1, then 1 over a minus 1 does not converge, and therefore the value of this integral is undefined from 0 to 3. So the value of this integral does not converge, and the integral is said to be undefined. Here we'd like to integrate x minus 1 to the power minus 2/3 between the limits 0 and 4. And although the function is defined at its limits 0 and 4, we can see that the function is undefined at x equals 1 and that the required area crosses this undefined value. So in order to deal with this integral, we're going to let the problematic value become a. So this will become the integral from 0 to a of x minus 1 to minus 2/3 dx, and we're going to see what happens to that integral as the limit as a gets closer and closer to 1. And then we're also going to look at the integral from a to 4 of x minus 1 to the minus 2/3 dx, and see what happens to that integral as the limit as a gets closer and closer to 1. So we've got the limit as a gets closer to 1, so this is doing the integral from 0 to a is 3 x minus 1 to the 3rd, and its limits are 0 up to a. And then the second integral will be 3 x minus 1 to the 3rd, and its limits will be a to 4. Now we can sub in the limits. So subbing in the top limit, you get 3 a minus 1 to the third minus 3 minus 1 to the third. That's both limits subbed in. And then moving on to the second integral, subbing both limits in. So subbing in the 4 is 3 times 3 to the third minus, and the bottom limit going in, 3 a minus 1 to the third. Now, as a approaches its limit of 1, a minus 1 will approach 0, and therefore the integral becomes convergent, and the integral will converge on the value 3 plus 3 times 3 to the third. So the integral does converge on a value, and we can find that value by splitting the interval at the problem value, which in this case was 1, and then seeing what happens as a approaches that problematic value. So the process is to split the integral at the problem value and replace with a variable. In this case we've used a, and then having evaluated the integrals, we then look at what happens in the limiting case as the variable a approaches its true value, which in this case was 1. And that brings us to the end of Calculus 2, Improper Integrals.